Part 2. The Web Tier. Part 2 explores the technologies in the Web Tier. This part contains the following chapters. Chapter 3, Getting Started with Web Applications. Chapter 4, Java Server Faces Technology. Chapter 5, Introduction to Facelets. Chapter 6, Expression Language. Chapter 7, Using Java Server Faces Technology in Web Pages. Chapter 8, Using Converters, Listeners, and Validators. Chapter 9, Developing with Java Server Faces Technology. Chapter 10, Java Server Faces Technology Advanced Concepts. Chapter 11, Configuring Java Server Faces Applications. Chapter 12, Using AJAX with Java Server Faces Technology. Chapter 13, Advanced Composite Components. Chapter 14, Creating Custom UI Components. Chapter 15, Java Servlet Technology. Chapter 16, Internationalizing and Localizing Web Applications. Getting Started with Web Applications. A web application is a dynamic extension of a web or application server. Web applications are of the following types. Presentation-oriented. A presentation-oriented web application generates interactive web pages containing various types of markup language, HTML, XHTML, XML, and so on, and dynamic content in response to requests. Development of presentation-oriented web applications is covered in Chapter 4, Java Server Faces Technology, through Chapter 9, Developing with Java Server Faces Technology. Service-oriented. A service-oriented web application implements the endpoint of a web service. Presentation-oriented applications are often clients of service-oriented web applications. Development of service-oriented web applications is covered in Chapter 18, Building Web Services with JAX-RS, and Chapter 19, Building RESTful Web Services with JAX-RS. In Part 3, Web Services. The following topics are addressed here. Web applications, web application lifecycle, web modules. The Hello 1 example, configuring web applications. The Hello 2 example, further information about web applications, web applications. In the Java EE platform, web components provide the dynamic extension capabilities for a web server. Web components can be Java Servlets, web pages implemented with Java Server Faces technology, web service endpoints, or JSP pages. Figure 3-1 illustrates the interaction between a web client and a web application that uses a servlet. The client sends an HTTP request to the web server. A web server that implements Java Servlet and Java Server Pages technology converts the request into an HTTP servlet request object. This object is delivered to a web component, which can interact with JavaBeans components or a database to generate dynamic content. The web component can then generate an HTTP servlet response or can pass the request to another web component. A web component eventually generates a HTTP servlet response object. The web server converts this object to an HTTP response and returns it to the client. Figure 3-1 Java Web Application Request Handling. Servlets are Java programming language classes that dynamically process requests and construct responses. Java technologies, such as Java Server Faces and Facelets, are used for building interactive web applications. Frameworks can also be used for this purpose. Although servlets and Java Server Faces and Facelets pages can be used to accomplish similar things, each has its own strengths. Servlets are best suited for service-oriented applications. Web service endpoints can be implemented as servlets, and the control functions of a presentation-oriented application, such as dispatching requests and handling non-textual data. Java Server Faces and Facelets pages are more appropriate for generating text-based markup, such as XHTML, and are generally used for presentation-oriented applications. Web components are supported by the services of a runtime platform called a web container. A web container provides such services as request dispatching, security, concurrency, and lifecycle management. A web container also gives web components access to such APIs as naming, transactions, and email. Certain aspects of web application behavior can be configured when the application is installed or deployed to the web container. The configuration information can be specified using Java EE annotations or can be maintained in a text file in XML format called a Web Application Deployment Descriptor (DD). A Web Application DD must conform to the schema described in the Java Servlet specification. This chapter gives a brief overview of the activities involved in developing web applications. First, it summarizes the web application lifecycle and explains how to package and deploy very simple web applications on the GlassFish server. The chapter moves on to configuring web applications and discusses how to specify the most commonly used configuration parameters. Web application lifecycle. A web application consists of web components, static resource files, such as images, and helper classes and libraries. The web container provides many supporting services that enhance the capabilities of web components and make them easier to develop. However, because a web application must take these services into account, the process for creating and running a web application is different from that of traditional standalone Java classes. The process for creating, deploying, and executing a web application can be summarized as follows. Develop the web component code. Develop the web application deployment descriptor, if necessary. Compile the web application components and helper classes referenced by the components. Optionally, package the application into a deployable unit. Deploy the application into a web container. Access a URL that references the web application. Developing web component code is covered in the later chapters. Steps 2 through 4 are expanded on in the following sections and illustrated with a Hello World-style presentation-oriented application. This application allows the user to enter a name into an HTML form figure 3-2 and then displays a greeting after the name is submitted figure 3-3. Figure 3-2 greeting form for Hello One web application. Figure 3-3 response page for Hello One web application. The Hello application contains two web components that generate the greeting and the response. This chapter discusses the following simple applications. Hello 1, a Java Server Faces technology-based application that uses two XHTML pages and a backing bean. Hello 2, a servlet-based web application in which the components are implemented by two servlet classes. The applications are used to illustrate tasks involved in packaging, deploying, configuring, and running an application that contains web components. The source code for the examples is in the tut install. Examples: Web, Hello 1, and tut install. Examples: Web, Hello 2. Directories, Web Modules. The Hello 1 example. In the Java EE architecture, web components and static web content files, such as images, are called web resources. A web module is the smallest deployable and usable unit of web resources. A Java EE web module corresponds to a web application as defined in the Java Servlet specification. In addition to web components and web resources, a web module can contain other files, server-side utility classes, such as shopping carts, client-side classes, such as applets, and utility classes. A web module has a specific structure. The top-level directory of a web module is the document root of the application. The document root is where XHTML pages, client-side classes and archives, and static web resources, such as images, are stored. The document root contains a subdirectory named WEB INF, which can contain the following files and directories. Classes, a directory that contains server-side classes. Servlets, enterprise bean class files, utility classes, and JavaBeans components. Tags, a directory that contains tag files, which are implementations of tag libraries. Lib, a directory that contains jar files that contain enterprise beans, and jar archives of libraries called by server-side classes. Deployment descriptors, such as Web, XML, the web application deployment descriptor, and EJB jar. XML and EJB deployment descriptor. A web module needs a web XML file if it uses Java Server Faces technology, if it must specify certain kinds of security information, or if you want to override information specified by web component annotations. You can also create application-specific subdirectories, that is, package directories in either the document root or the web inf. Classes. Directory. A web module can be deployed as an unpacked file structure or can be packaged in a jar file known as a web archive WAR file. Because the contents and use of WAR files differed from those of jar files, WAR file names use a WAR extension. The web module just described is portable. You can deploy it into any web container that conforms to the Java Servlet specification. To deploy WAR on the GlassFish server, the file must contain a runtime deployment descriptor. The runtime DD is an XML file that contains such information as the context root of the web application and the mapping of the portable names of an application's resources to the GlassFish server's resources. The GlassFish server web application runtime DD is named glassfish-web.xml and is located in the web inf directory. The structure of a web module that can be deployed on the GlassFish server is shown in Figure 3-4. For example, the glassfish-web.xml file for the hello1 application specifies the following context root. Context root, hello1. Context root. Figure 3-4 web module structure. Examining the hello1 web module. The hello1 application is a web module that uses Java Server Faces technology to display a greeting and response. You can use a text editor to view the application files, or you can use NetBeans IDE. To view the hello1 web module using NetBeans IDE, from the File menu, choose Open Project. In the Open Project dialog, navigate to Tut Install. Examples. Web. Select the hello1 folder. Select the Open as Main Project checkbox. Expand the Web Pages node and double-click the index.html file to view it in the right-hand pane. The index.html file is the default landing page for a Facelets application. For this application, the page uses simple tag markup to display a form with a graphic image, a header, a text field, and 2 command buttons. XML version equal 1. 0 encoding equal UTF-8. Type HTML public. W3C. DTDX-HTML1. 0 transitional. N. HTTP. W3. Org. TR. XHTML1. DTD. XHTML1 transitional. DTD. HTML XMLNS equal HTTP. W3. Org. 1999. XHTML XMLNS. Our equal HTTP. Java. Sun. Com. JSF. HTML. H. Head. Title. Facelets hello greeting. Title. H. Head. H. Body. H. Form. H. Graphic image URL equal div. Waving. GIF. H2. Hello, my name is Dick. What's yours? H2. H. Input text it equal username value equal hello. Name required equal true required message equal a name is required. Max length equal 25. H. Input text. P. P. H. Command button it equal submit value equal submit action equal response. H. Command button. H. Command button it equal reset value equal reset type equal reset. H. Command button. H. Form. H. Body. HTML. The most complex element on the page is the input text field. The max length attribute specifies the maximum length of the field. The required attribute specifies that the field must be filled out. The required message attribute provides the error message to be displayed if the field is left empty. Finally, the value attribute contains an expression that will be provided by the hello backing bean. The submit command button element specifies the action as response, meaning that when the button is clicked, the response XHTML page is displayed. Double-click the response XHTML file to view it. The response page appears. Even simpler than the greeting page, the response page contains a graphic image, a header that displays the expression provided by the backing bean, and a single button whose action element transfers you back to the index.html page. XML version equal 1. 0 encoding equal UTF-8. Type HTML public. W3C. DTDX-HTML1. 0 transitional. ENHTTP. W3. Org. TR. XHTML1. DTD. XHTML1 transitional. DTD. HTML XMLNS equal HTTP. W3. Org. 1999. XHTML XMLNS. Our equal HTTP. Java. Sun. Com. JSF. HTML. H. Head. Title. Facelets hello response. Title. H. Head. H. Body. H. Form. H. Graphic image URL equal doc. Waving. GIF. H2. Hello. Hello. Name. H2. P. P. H. Command button it equal back value equal back action equal index. H. Form. H. Body. HTML. Expand the source packages node, then the hello on node. Double-click the hello Java file to view it. The hello class, called a backing bean class, provides getter and setter methods for the name property used in the facelets page expressions. By default, the expression language refers to the class name, with the first letter in lowercase hello. Name. Package hello1, import javax. Faces. Bean. Manage bean, import javax. Faces. Bean. Request scoped, manage bean. Request scope public class hello private string name, public hello, public string get name return name. Public void set name string username this. Name equal username. Under the web pages node, expand the web inf node and double-click the web XML file to view it. The web XML file contains several elements that are required for a facelets application. All these are created automatically when you use NetBeans IDE to create an application. A context parameter specifying the project stage, context param, param name, javax. Faces. Project stage. Param name, param value, development. Param value, context param. A context parameter provides configuration information needed by a web application. An application can define its own context parameters. In addition, Java Server Faces technology and Java Servlet technology define context parameters that an application can use. A servlet element and its servlet mapping element specifying the faces servlet, servlet name, faces servlet, servlet name, servlet class, javax. Faces. WEB Faces servlet. Servlet class, load on startup, 1. Load on startup, servlet, servlet mapping, servlet name. Faces servlet. Servlet name, URL pattern. Faces. URL pattern, servlet mapping. A welcome file list element specifying the location of the landing page. Note that the location is faces. Index. XHTML, not just index. XHTML, welcome file list, welcome file, faces, index. XHTML, welcome file list. Packaging a web module. A web module must be packaged into a WAR in certain deployment scenarios and whenever you want to distribute the web module. You package a web module into a WAR by executing the jar command in the directory laid out on the format of a web module, by using the int utility, or by using the IDE tool of your choice. This tutorial shows you how to use NetBeans IDE or int to build, package, and deploy the Hello One sample application. To set the context root, A context root identifies a web application in a Java EE server. A context root must start with a / and end with a string. In a packaged web module for deployment on the GlassFish server, the context root is stored in glassfish-web.xml. To view or edit the context root, follow these steps. Expand the web pages and web inf nodes of the Hello1 project. Double-click glassfish-web.xml. In the General tab, observe that the context root field is set to Hello1. If you needed to edit this value, you could do so here. When you create a new application, you type the context root here. Optional, click the XML tab. Observe that the context root value Hello1 is enclosed by the context root element. You could also edit the value here. To build and package the Hello1 web module using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to Tut Install. Examples. Web. Select the Hello1 folder. Select the Open as Main Project checkbox. Click Open Project. In the Projects tab, right-click the Hello1 project and select Build. To build and package the Hello1 web module using it. In a terminal window, go to Tut Install. Examples. Web. Hello1. Type the following command, and this command spawns any necessary compilations, copies files to the directory tut install. Examples. Web. Hello1. Build. Creates the WAR file, and copies it to the directory tut install. Examples. Web. Hello1. Dist. Deploying a web module. You can deploy a WAR file to the GlassFish server by using NetBeans IDE, using the ant utility, using the sysadmin command, using the administration console, copying the WAR file into the domain dir. Autodeploy. Directory. Throughout the tutorial, you will use NetBeans IDE or ant for packaging and deploying. To deploy the Hello1 web module using NetBeans IDE, right-click the Hello1 project and select Deploy. To deploy the Hello1 web module using it. In a terminal window, go to Tut Install. Examples. Web. Hello1. Type the following command, and deploy running a deployed web module. Now that the web module is deployed, you can view it by opening the application in a web browser. By default, the application is deployed to host localhost on port 8080. The context root of the web application is Hello1. To run a deployed web module, open the web browser. Type the following URL, http localhost 8080 Hello1. Type your name and click Submit. The response page displays the name you submitted. Click the back button to try again. Listing deployed web modules. The GlassFish server provides two ways to view the deployed web modules. The administration console and the sysadmin command. To list deployed web modules using the administration console, open the URL http localhost 4848 in a browser. Select the Applications node. The deployed web modules appear in the Deployed Applications table. To list deployed web modules using the sysadmin command, type the following command, sysadmin list applications. Updating a web module. A typical iterative development cycle involves deploying a web module and then making changes to the application components. To update a deployed web module, follow these steps. To update a deployed web module, recompile any modified classes. Redeploy the module. Reload the URL in the client. Dynamic reloading. If dynamic reloading is enabled, you do not have to redeploy an application or a module when you change its code or deployment descriptors. All you have to do is copy the changed pages or class files into the deployment directory for the application or module. The deployment directory for a web module named context root is domain dir. Applications. Context root. The server checks for changes periodically and redeploys the application automatically and dynamically with the changes. This capability is useful in a development environment because it allows code changes to be tested quickly. Dynamic reloading is not recommended for a production environment, however, because it may degrade performance. In addition, whenever reload is done, the sessions at that time become invalid, and the client must restart the session. In the GlassFish server, dynamic reloading is enabled by default. To disable or modify dynamic reloading, if for some reason you do not want the default dynamic reloading behavior, follow these steps in the administration console. Open the URL http localhost 4848 in a browser. Select the GlassFish server node. Select the Advanced tab. To disable dynamic reloading, deselect the Reload Enable checkbox. To change the interval at which applications and modules are checked for code changes and dynamically reloaded, type a number of seconds in the reload pol interval field. The default value is 2 seconds. Click the Save button. Undeploying Web Modules. You can undeploy web modules and other types of enterprise applications by using either NetBeans IDE or the Ant tool. To undeploy the Hello One web module using NetBeans IDE, ensure that the GlassFish server is running in the Services window. Expand the Servers node, GlassFish server instance, and the Applications node. Right-click the Hello One module and choose Undeploy. To delete the class files and other build artifacts, right-click the project and choose Clean. To undeploy the Hello One web module using Ant, in a terminal window, go to tut install. Examples: web hello one. Type the following command, ant undeploy. To delete the class files and other build artifacts, type the following command, ant clean. Configuring web applications, the Hello 2 example. Web applications are configured by means of annotations or by elements contained in the web application deployment descriptor. The following sections give a brief introduction to the web application features you will usually want to configure. Examples demonstrate procedures for configuring the Hello World application. Mapping URLs to web components. When it receives a request, the web container must determine which web component should handle the request. The web container does so by mapping the URL path contained in the request to the web application and the web component. A URL path contains the context root and, optionally, a URL pattern. HTTP, host, port, context root, URL pattern. You set the URL pattern for a servlet by using the web servlet annotation in the servlet source file. For example, the greeting servlet Java file in the Hello 2 application contains the following annotation, specifying the URL pattern as greeting web servlet. Greeting public class greeting servlet extends HTTP servlet. This annotation indicates that the URL pattern greeting follows the context root. Therefore, when the servlet is deployed locally, it is accessed with the following URL, http localhost 8080 hello 2 greeting. To access the servlet by using only the context root, specify semicolon as the URL pattern. Examining the Hello 2 web module. The Hello 2 application behaves almost identically to the Hello 1 application, but it is implemented using Java Servlet technology instead of Java Server Faces technology. You can use a text editor to view the application files, or you can use NetBeans IDE to view the Hello 2 web module using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to tut install. Examples: web. Select the Hello 2 folder. Select the Open as Main Project checkbox. Expand the Source Packages node, then the Servlets node. Double-click the Greeting Servlet Java file to view it. This servlet overrides the do-get method, implementing the get method of HTTP. The servlet displays a simple HTML greeting form whose submit button, like that of Hello 1, specifies a response page for its action. The following excerpt begins with a web servlet annotation that specifies the URL pattern relative to the context root, web servlet. Greeting public class greeting servlet extends HTTP servlet. Override public void do get HTTP servlet request HTTP servlet response throws servlet exception exception response set content type text HTML response set buffer size 8192 print writer out equal response get writer then write the data of the response out println HTML plus head title servlet hello title head then write the data of the response out println body color equal FFFFFF semicolon plus imgsrc equal Duke waving GIF alt equal Duke waving semicolon plus H2 hello, my name is Duke, what's yours? H2 plus form method equal get semicolon plus input type equal text name equal username size equal 25 semicolon plus p plus input type equal submit value equal submit semicolon plus input type equal reset value equal reset semicolon plus form string username equal request get parameter username if username equal null username length 0 request dispatcher equal get servlet context get request dispatcher response if dispatcher equal null dispatcher include request response out println body HTML out close double click the response servlet Java file to view it. This servlet also overrides the doGet method, displaying only the response. The following excerpt begins with a Web Servlet annotation, which specifies the URL pattern relative to the context root. Web Servlet response public class ResponseServlet extends HTTP servlet. Override public void do get HTTP servlet request HTTP servlet response throws servlet exception exception print writer out equal response get writer then write the data of the response string username equal request get parameter username if username equal null username length 0 out println h2 hello plus username plus h2 under the web pages node expand the WEB INF node and double click the glassfish-web.xml file to view it. In the General tab, observe that the context root field is set to hello 2. For this simple servlet application, a web XML file is not required. Building, packaging, deploying, and running the hello 2 example. You can use either NetBeans IDE or to build, package, deploy, and run the hello 2 example. To build, package, deploy, and run the hello 2 example using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to Tut Install. Examples. Web. Select the hello 2 folder. Select the Open as Main Project checkbox. Click Open Project. In the Projects tab, right-click the hello 2 project and select Build. Right-click the project and select Deploy. In a web browser, open the URL http localhost 8080 hello 2 greeting. The URL specifies the context root, followed by the URL pattern. The application looks much like the Hello 1 application shown in Figure 3-2. The major difference is that after you click the Submit button, the response appears below the greeting, not on a separate page. To build, package, deploy, and run the hello 2 example using it. In a terminal window, go to Tut Install. Examples. Web. hello2. Type the following command, and this target builds the WAR file and copies it to the tut install. Examples: web, hello2, dist, directory. Type and deploy. Ignore the URL shown in the deploy target output. In a web browser, open the URL http localhost 8080 hello2. Greeting. The URL specifies the context root, followed by the URL pattern. The application looks much like the Hello 1 application shown in Figure 3-2. The major difference is that after you click the Submit button, the response appears below the greeting, not on a separate page. Declaring welcome files. The welcome files mechanism allows you to specify a list of files that the web container will use for appending to a request for URL called a valid partial request that is not mapped to a web component. For example, suppose that you define a welcome file welcome.html when a client requests a URL such as host, port, WEB directory, where directory is not mapped to a servlet or XHTML page. The file host, port, WEB directory, welcome HTML is returned to the client. If a web container receives a valid partial request, the web container examines the welcome file list and appends to the partial request each welcome file in the order specified and checks whether a static resource or servlet in the WAR is mapped to that request URL. The web container then sends the request to the first resource that matches in the WAR. If no welcome file is specified, the GlassFish server will use a file named index.html as the default welcome file. If there is no welcome file and no file named index.html, the GlassFish server returns a directory listing. By convention, you specify the welcome file for a Java Server Faces application as faces. File name, XHTML. Setting context and initialization parameters. The web components in a web module share an object that represents their application context. You can pass initialization parameters to the context or to a web component. To add a context parameter using NetBeans IDE. These steps apply generally to web applications, but do not apply specifically to the examples in this chapter. Open the project. Expand the projects node in the projects pane. Expand the web pages node and then the web inf node. Double-click web XML. If the project does not have a web XML file, follow the steps in to create a web XML file using NetBeans IDE. Click General at the top of the editor pane. Expand the context parameters node. Click Add, an Add Context Parameter dialog opens. In the parameter name field, type the name that specifies the context object. In the parameter value field, type the parameter to pass to the context object. Click OK to create a web XML file using NetBeans IDE. From the File menu, choose New File. In the New File wizard, select the web category, then select Standard Deployment Descriptor under File Types. Click Next. Click Finish. An empty web XML file appears in WEB INF. To add an initialization parameter using NetBeans IDE, you can use the Web Servlet annotation to specify web component initialization parameters by using the initprims attribute and the Web init param annotation. For example, Web Servlet URL patterns equal my pattern initprims equal Web init param name equal CCC value equal 333. Alternatively, you can add an initialization parameter to the web XML file. To do this using NetBeans IDE, follow these steps. These steps apply generally to web applications, but do not apply specifically to the examples in this chapter. Open the project. Expand the projects node in the projects pane. Expand the web pages node and then the web inf node. Double-click web XML. If the project does not have a web XML file, follow the steps in to create a web XML file using NetBeans IDE. Click Servlets at the top of the editor pane. Click the Add button under the Initialization Parameters table. An Add Initialization Parameter dialog opens. In the parameter name field, type the name of the parameter. In the parameter value field, type the parameter's value. Click OK. Mapping errors to error screens. When an error occurs during execution of a web application, you can have the application display a specific error screen according to the type of error. In particular, you can specify a mapping between the status code returned in an HTTP response or a Java programming language exception returned by any web component in any type of error screen. You can have multiple error page elements in your deployment descriptor. Each element identifies a different error that causes an error page to open. This error page can be the same for any number of error page elements. To set up error mapping using NetBeans IDE. These steps apply generally to web applications, but do not apply specifically to the examples in this chapter. Open the project. Expand the projects node in the projects pane. Expand the web pages node and then the web inf node. Double-click Web XML. If the project does not have a Web XML file, follow the steps in to create a Web XML file using NetBeans IDE. Click Pages at the top of the editor pane. Expand the Error Pages node. Click Add. The Add Error Page dialog opens. Click Browse to locate the page that you want to act as the error page. In the error code field, type the HTTP status code that will cause the error page to be opened, or leave the field blank to include all error codes. In the exception type field, type the exception that will cause the error page to load. To specify all exceptions, type Java lang trowable. Click OK. Declaring resource references. If your web component uses such objects as enterprise beans, data sources, or web services, you use Java EE annotations to inject these resources into your application. Annotations eliminate a lot of the boilerplate lookup code and configuration elements that previous versions of Java EE required. Although resource injection using annotations can be more convenient for the developer, there are some restrictions on using it in web applications. First, you can inject resources only into container-managed objects, since a container must have control over the creation of a component so that it can perform the injection into a component. As a result, you cannot inject resources into such objects as simple JavaBeans components. However, Java Server Faces managed beans are managed by the container. Therefore, they can accept resource injections. Components that can accept resource injections are listed in Table 3-1. This section explains how to use a couple of the annotations supported by a servlet container to inject resources. Chapter 33, Running the Persistence Examples, explains how web applications use annotations supported by the Java Persistence API. Chapter 40, Getting Started Securing Web Applications, explains how to use annotations to specify information about securing web applications. Table 3-1 Web Components that accept resource injections component interface. Class Servlets JAX. Servlet. Servlet filters. JAX. Servlet. Servlet filter event listeners JAX. Servlet. Servlet context listener JAX. Servlet. Servlet context attribute listener JAX. Servlet. Servlet request listener JAX. Servlet. Servlet request attribute listener JAX. Servlet. HTTP HTTP session listener JAX. Servlet. HTTP HTTP session attribute listener JAX. Servlet. HTTP HTTP session binding listener to glib listener same as above to glib tag handlers JAX. Servlet. JSP. Tagxt. JSP tag managed beans plain old Java objects declaring a reference to a resource. The resource annotation is used to declare reference to a resource, such as a data source, an enterprise bean, or an environment entry. The resource annotation is specified on a class, a method, or a field. The container is responsible for injecting references to resources declared by the resource annotation and mapping it to the proper JNDI resources. In the following example, the resource annotation is used to inject a data source into a component that needs to make a connection to the data source, as is done when using JDBC technology to access a relational database. Resource javax.sql. Data source catalogs. Public get products by category. Get a connection and execute. The query connection con equal catalog ds. Get connection. The container injects this data source prior to the components being made available to the application. The data source JNDI mapping is inferred from the field name catalog ds and the type javax.sql. Data source. If you have multiple resources that you need to inject into one component, you need to use the resources annotation to contain them, as shown by the following example. Resources. Resource name equal mydb type equal java. SQL. Data source. Resource name equal mymq type equal javax. JMS. Connection factory. The web application examples in this tutorial use the Java Persistence API to access relational databases. This API does not require you to explicitly create a connection to a data source. Therefore, the examples do not use the resource annotation to inject a data source. However, this API supports the persistence unit and persistence context annotations for injecting Entity Manager Factory and Entity Manager instances, respectively. Chapter 33, Running the Persistence Examples describes these annotations and the use of the Java Persistence API in web applications. Declaring a reference to the web service. The web service ref annotation provides a reference to the web service. The following example uses the web service ref annotation to declare a reference to the web service. Web service ref uses the WSDL location element to specify the URI of the deployed service's WSDL file. Import javax.xml. WS. Web service ref. Public class ResponseServlet extends HTTPS servlet. Web service ref WSDL location equal HTTP. Localhost 8080. Hello service. Hello? WSDL static hello service. Further information about web applications. For more information on web applications, see Java Server Faces 2.0 specification, HTTP, JCP, org, N, JSR, detail, id equal 314. Java Server Faces Technology website, http, Oracle, com, Tech Network, Java, JavaE, Java Server Faces 139869, HTML, Java Servlet 3.0 specification, HTTP, JCP, org, N, JSR, detail, id equal 315. Java Servlet website. HTTP. Oracle. Com. Tech Network. Java. Index.jsp 135475. HTML.